Hi everyone, I'm going to show you guys how to solve this integral, and it's an MIT question from 2024. The thing is, it's different because the one in 2024 had intervals, but this doesn't have intervals. I just thought of integrating this question without any intervals so that I can show you of what the answer really is. The one you had in the exams is different because when you have intervals, there are different methods you can follow to get the final answer, but you don't have to actually integrate the whole thing to get the final answer if you have intervals. But I'm going to show you guys of how to integrate like without any intervals, like how do you actually integrate this using substitutions, using the basic methods. Okay, so I'll be showing that to you guys today. So what you could do is you could take a substitution of u equals tan x to the power 1 over 3. Now cubic root means to the power 1 over 3, right? It's the same thing. So then du over dx, the differentiation would be, so 1 over 3 comes down, you differentiate of what you have inside the brackets, which is sec squared x into tan x to the power 1 over 3 minus 1, which is minus 2 over 3, right? So you could rewrite this as sec squared x over 3 into tan x to the power 2 over 3. So du over dx equals to that. Now I can write 3 tan x to the power 2 over 3 over sec squared x equals to, dot du equals dx. Now this is the substitution you go, right? Let's go back into your question. Your numerator is tan x to the power 1 over 3 over sin x plus cos x in brackets to the power 2. Instead of dx, I'm going to write 3 tan x to the power 2 over 3 over sec squared x dot dx, right? Okay, now let's multiply the numerators together. I'll just take the 3 outside for now. So tan x to the power 1 over 3 into tan x to the power 2 over 3 is tan x, right? Tan x to the power 3 over 3, so which is tan x, easy. Tan x over sec squared x into, now let's expand sin x plus cos x to the power 2. So that would be sin squared x plus 2 sin x cos x plus cos squared x, right? And this would be 1 plus 2 sin x cos x. So as you can see, sin squared plus cos squared x is going to be 1. So instead of writing sin x plus cos x in brackets to the power 2, you could write 1 plus 2 sin x cos x. Oh, and I'm sorry, when I took the substitution, this has to be du, alright, because this was the substitution. I by mistake put dx, so du. Now what you do is you have to change all these x terms into u terms, right? I'll expand the brackets at the denominator, so we have tan x over sec squared x plus 2 sin x. Now sec squared x is cos squared x, right? 1 over cos squared x. So it's going to be 2 sin x over cos squared x into cos x, right? Dot d. You can see these will cancel off, and you'll have sin x over cos x, meaning it would be 2 tan x, right? Okay, now let's go to our substitutions. So we had u equals tan x to the power 1 over 3. So if u equals tan x to the power 1 over 3, what's tan x? So if you cube both sides, you put to the power 3 on both sides, then you can see tan x equals to u to the power 3. And then you know tan squared x plus 1 equals to sec squared x. So then u to the power 6 plus 1 equals sec squared x. Let's go back into our question. So tan x is going to be u to the power 3 over sec squared x is u to the power 6 plus 1 plus 2 into tan x, which is u to the power 3 dot du. So now it's going to be u to the power 3 over u to the power 6 plus 2 u to the power 3 plus 1 dot du. Okay, so it's now if you look at the denominator, u to the power 6 plus 2 u to the power 3 plus 1, you can rewrite it as u to the power 3 plus 1 in brackets squared. If you expand this, you get u to the power 6 plus 2 u to the power 3 plus 1. Yeah. So then you rewrite this as 3 into u to the power 3 over u to the power 3 plus 1 brackets to the power 2 dot du. Okay, it's getting easier and easier every step, but it's not it will take you some time, you know, to solve this question. So then what you do is, now I'm thinking of using integration by parts. You know what, now the formula for integration by parts is uv minus the integration of v into du over dx dot dx, right? This is the formula for integration by parts. Now the formula has u and v. Now the integration I have has u, right? So let me just change them into t. I'll just write u equals to t. Don't get confused, alright? There's nothing big going on. I'm just making u equals to t. No big difference. It's just I'm going to change the letters. That's it. Then our formula would be dt dot dt. So I'll rewrite the question as 3 into t to the power 3 over t to the power 3 plus 1 squared dot dt. Alright, I just changed the u into t. That's it. I didn't notice that I'll have to use integration by parts while doing this question. I just realized right now, because I think integration by parts would be the best for that integral. So now I'm gonna take it like this: 3 into, I'll write t into t squared into t to the power 3 plus 1 in brackets to the power minus 2. I just took the denominator to the top, and I'll also take 3 inside this time. I'll write t into 3t squared. You'll see why. Now I'll take u equals to t and dv over dt equals to 3t squared into t to the power 3 plus 1 in brackets to the power minus 2. So du over dt equals to 1, and now we need to find v. All you have to do is integrate this. So how do you integrate that? It's easy. If you look carefully, if you differentiate of what you have inside the brackets, you can see you'll get 3t squared, which is right at the front, right? So if I write it down like this, the differential of t to the power 3 plus 1 into t to the power 3 plus 1 in brackets to the power minus 2. So if you look at it like that, you can see if you differentiate 1 over t to the power 3 plus 1, you'll be getting that answer, or with a minus in front. Let me show it to you guys. So how do you differentiate this now? So t to the power 3 plus 1 to the power minus 1 with a minus in front. The minus 1 will come down, meaning it would be 1 into t to the power 3 plus 1, and minus 1, the power gets subtracted by 1, so it becomes minus 2 into the differentiation of what you have inside the brackets, which is 3t squared, giving you the same exact thing, right? So yeah, v equals to this. Now using your formula, u into v is t over t to the power 3 plus 1 minus v. So v is minus 1 over t to the power 3 plus 1. So you have two negative values, so it would just be plus. So 1 over t to the power 3 plus 1 dot dt. This is what you have to integrate. Once you integrate that, you'll get your final answer. Now we are 11 minutes in. This will take another around 6 or 7 minutes since I'm explaining. So bear with me, alright? And if you guys have any doubts, please drop a comment. I'll help you guys out. Now when integrating 1 over t to the power 3 plus 1 dot dt, now what are we gonna do? We'll have to take partial fractions, right? We'll have to write 1 over t to the power 3 plus 1 in partial fractions. First, we'll have to find the factors of t to the power 3 plus 1. So if you substitute t equals minus 1, you'll see that you'll get 0, right? Meaning t plus 1 is a factor. So if you divide t to the power 3 plus 1, so I'll write it like this. So it's easier for you guys to understand. If I divide it by t plus 1, we'll see t squared into t to the power 3 plus t squared minus t squared plus 0t minus t squared plus, so minus t plus 1 plus 1 plus 1 into t plus 1 0. Yeah, so you can see t plus 1 into t squared minus t plus 1 gives you t to the power 3 plus 1. So 1 over t to the power 3 plus 1, you can write it as 1 over t plus 1 into t squared minus t plus 1. Now which you can also write as a over t plus 1 plus b t plus c over t squared minus t plus 1 in partial fraction formats. Okay, now if you multiply every single term by t to the power 3 plus 1, you have 1 equals to a into t squared minus t plus 1 plus bt plus c into t plus 1. Now guys, if you guys have any doubts with partial fractions, please drop a comment. I'll help you guys out. Okay, now if I substitute, let's say when t equals 0, when t equals 0, 1 equals to a plus c. Okay, and when t equals to 1, you can write 1 equals to, when you substitute 1, you have a plus b plus c into 2, right? So we have 1 equals a plus 2b plus 2c. That's our second equation. And if you substitute t equals minus 1, we'll have 1 equals to a into, so minus 1 squared is 1 minus minus into minus 1, so it's plus 1 plus 1, so it's just 3a plus bt plus c into 0, right? So it's just going to be 1 equals to 3a. So a equals to 1 over 3. If a equals to 1 over 3, using that you can write 1 equals 1 over 3 plus c. C equals to 2 over 3. And then what would b be? So 1 equals to 1 over 3 plus 2b plus 2 into 2 over 3. So 1 equals to 1 over 3 plus 4 over 3 is 5 over 3 plus 2b. So when 5 over 3 goes on to the other side, you'll have negative 2 over 3 equals to 2b. b equals to negative 1 over 3. Now we found ABC. So you could write your partial fraction as 1 over 3 into t plus 1 minus, I'll take the minus out, so it would be t minus 2 over 3 into t squared minus t plus 1. Now this is 1 over t to the power 3 plus 1 in partial fractions, alright? Okay, so instead of integrating 1 over t to the power 3 plus 1, now we can integrate this 1 over 3 into t plus 1 minus t minus 2 over 3 into t squared minus t plus 1 dot dt. Now how do you integrate the terms the fraction we have on the left side? Easy, right? 1 over 3 into ln t plus 1. Yeah, okay, so that's that. Now let's go on to the integral on the right side. Let's leave the minus for now. Let's just focus on t minus 2 over 3 into t squared minus t plus 1 dot dt. Now what I'm going to do is I'm going to multiply the denominator and numerator by 2. So you'll have 2t minus 4 over 6 into t squared minus t plus 1. The reason I'm doing that is because when you differentiate t squared minus t plus 1, you'll have 2t minus 1. But if you look at our numerator, we don't have 2t minus 1, right? So we need to get 2t minus 1 for our numerator so that we can solve the integral in an easier way. So now I could write this as 2t minus 1 minus 3, right, over 6 to t squared minus t plus 1 dot dt. Now I could break this down to 2t minus 1 over, I could take the 6 out, t squared minus t plus 1 dot dt plus 1 over 6 into, oh, it's not plus, it's minus because there's a minus, minus 3 over t squared minus t plus 1 dot dt. And the 3's will cancel off, so it's just going to be 2. This would be 1. Now if you look at the fraction you have on the left side, what would that be? What would that give you? So if we just differentiate ln t squared minus t plus 1, you'll see, how do you differentiate this? 1 over t squared, 1 over t squared minus t plus 1 into the differentiation of what you have inside the bracket. So the differentiation of t squared minus t plus 1 is 2t minus 1. Can you see it's the same exact thing? So just all you have to do is just multiply this by 1 over 6 and you got the answer for the fraction on the left side. Now let's go on to the right side. We have minus half into the integration of 1 over t squared minus t plus 1. Now this is a bit tricky. We'll have to write this in a completing square format. So let's write t squared minus t plus 1 as t minus half squared minus half squared plus 1. So t minus half squared minus 1 over 4 plus 1 gives you 3 over 4, right? So then I could write minus half into the integration of 1 over t minus half squared plus 3 over 4 dot dt. What I'm going to do now is I'm going to take 3 over 4 outside. So when I take it outside, I have minus 1 over 2 into 4 over 3. We'll have 1 over t minus half squared over 3 over 4 plus 1. This is what I meant by taking 3 over 4 outside. So I could write this section as, I could put them in a bigger bracket as 1, but 3 over 4 would change. It would be root 3 over root 4, right? So root 4 is 2, so this is what you'll get. Now let's take a substitution of w equals t minus half over root 3 over 2. So dw over dt equals to 2 over root 3. I just took the reciprocal. Differentiation of t is just 1, so you could write root 3 over 2 dw equals to dt. And if you look here, you can see the numbers will cancel off, so it's minus 2 over 3, right, into the integration of 1 over, and the substitution, you put the substitution, w squared plus 1 into root 3 over 2 dw. Okay, I hope all of you guys understand. This is a really long question. If you guys have any doubts with any parts, please drop a comment. I'll help you guys out. Alright, okay, now you can see the 2's will cancel off, so it's negative root 3 over 3, and the integration of 1 over w squared plus 1 is tan inverse w squared, so w, so it's the integration of 1 over w squared plus 1 is tan inverse w. I've mentioned in my previous videos all the time. If you guys have any doubts with this, please drop a comment. The thing is, I don't show the methods is because these are basics of integration. You can directly memorize these integrals, but if you guys want me to show it, please drop a comment. Alright, so this would be negative root 3 over 3 tan inverse, and w was t minus half over root 3 over 2. If you take the reciprocal, you'll see it would be 2t minus 1 over root 3. Okay, so we've integrated the whole question. Now all we have to do is just put everything together. So if I go to the top, we had the first answer we had was this, t over t cubed plus 1, t over t cubed plus 1, and then we had, was it plus or minus? I need to recheck here. Plus 1 over 3 ln t plus 1. Okay, and then we had, now there was a minus in front over here. If you look carefully, this minus, so this answer would be minus negative 1 over 6. So negative 1 over 6 ln t squared minus t plus 1, and what else? So there was a minus in front of the whole thing, right? So then this would be plus when you expand. If you look carefully, right, you can see, because this minus would multiply with everything you have inside. So the answer we get for the next part, this one would actually be plus. So plus root 3 over 3 tan inverse 2t minus 1 over root 3 plus c. This is your final answer. But these are in terms of t, right? So I don't actually have to write it down again. You guys know the substitutions we took were to solve the integration by part section. I wrote u equals to t, which is the same thing. So all you have to do is just put in tan x to the power 1 over 3 instead of t, and that's your final answer. Alright, so that's everything for this question. If you guys have any doubts, please drop a comment. I'll help you guys out. And this was a really long question, so yeah, if you guys like my teaching, leave a like and subscribe. Have a great day. Thank you so much.